2025, artificial intelligence companies like OpenAI popularized the idea of automating the process of selecting which model is best for a task. This allowed users to simply send their prompt or request and let the system determine whether to respond using a fast or a slow reasoning model. In a 2022 paper, I suggested that this kind of strategic deployment of slow, more reflective reasoning could be crucial to good judgment and decision-making. Since then, I've been synthesizing the arguments and the evidence in favor of this view in a paper titled Strategic Reflectivism in Intelligent Systems. In this episode, I'll read the paper accepted by Lecture Notes in Computer Science, which argues that one key to intelligence in humans and machines is pragmatic switching between intuitive and reflective thinking based on the goals of the system. This episode's affiliate partner is Roadrunner Sports. For about a year, I've been adding a weekly marathon to my exercise routine. So shoes, socks, headphones, shorts, and other fitness products have felt more important to me lately. What I like about Roadrunner Sports is their integration of online and in-store retail. I can try things on in person, deliver to the store for free, return and exchange in person, or I could just do things online. To get your running needs met, check out my affiliate link to Roadrunner Sports in the description. Strategic Reflectivism in Intelligent Systems. Abstract. By the late 20th century, the rationality wars had launched debates about the nature and norms of intuitive and reflective thinking. Those debates drew from mid-20th century ideas such as bounded rationality, which challenged more idealized notions of rationality observed since the late 19th century. Now that 21st century cognitive scientists are applying the resulting dual process theories to artificial intelligence, it's time to dust off some lessons from this history. So this paper synthesizes old ideas with recent results from experiments on humans and machines. The result is strategic reflectivism, the position that one key to intelligent systems, human or artificial, is pragmatic switching between intuitive and reflective inference to optimally fulfill competing goals. Strategic reflectivism builds on American pragmatism, transcends superficial indicators of reflective thinking such as model size or chains of thought. It applies to both individual and collective intelligence systems, including human AI teams, and it becomes increasingly actionable as we learn more about the value of intuition and reflection. Introduction. There was a time when it seemed like the most mentioned feature of language models was their size. A vestige of this size-obsessed era of generative transformer model development was the first L in the acronym LLM. Consumer-friendly chatbots were large. But before chatbots were marketed for such broad use, terms like language model and GPT may have been preferred. This paper will argue that, among other things, we can become too obsessed with factors such as size, chains of thought, or other features of reasoning models. While these features may be related to the reflective thinking that many want from models, they are merely means to our ultimate ends, which are often in tension. So what we really need from intelligent systems are optimal trade-offs between these competing goals. This insight implies a kind of pragmatism about reasoning resources in humans, machines, or human-machine collaborations. Completing the details of this position requires a review of some ideas from history and more recent scientific discoveries. Section 2. It's not their size that matters, it's how you use them. Language models do begin to outperform humans when they reach a certain size, indicating that there is some benefit to larger language models. But what is it about large language models that help them outperform humans? In 2023, Aisapi and colleagues reported that as models increased in size, they were more likely to behave like a system called M-reasoner, especially its propensity for System 2, or reflective, thinking. Such results suggest that this capacity to reason reflectively probably matters at least as much as model size. 2.1. Reflection tests. Cognitive scientists have developed behavioral tests of reflective reasoning. The most famous reflection test question is the bat and ball problem. A bat and a ball cost $1.10 in total. The bat costs $1 more than the ball, so how much does the ball cost? Such reflection test questions are designed to lure people into accepting an alluring yet incorrect response, such as 10 cents. So we call these tests of System 2 or reflective thinking because they lure us into accepting a particular response that, with just a moment's reflection, we can realize is incorrect. Moreover, some reflection tests seem to measure the two components that feature prominently in philosophers' descriptions of reflective thinking: deliberate inhibition of one's initial intuition and conscious awareness of additional reasoning. Section 2.2. Superficial signs of reflection. So-called reasoning models appear to engage in multi-step reflection and often outperform humans on reflection tests. These two facts may lead you to conclude that what distinguishes reasoning models from language models is a capacity for reflective thinking. However, much like humans can often pass reflection tests without exhibiting any signs of reflective thinking, Hagendorf and colleagues found that language models continued to outperform humans on reflection tests even when they could not exhibit signs of reflective thinking, such as chain-of-thought reasoning. Thus, seemingly reflective chains of thought can be merely performative or inefficient. In some cases, chains of thought such as, "Wait, let me think about it," may even cause bias. So just as the size of language models can be overrated, so can indirect evidence of reflective thinking. Section 2.3. Romanticism about reflection. Philosophers have long thought that reflective reasoning is crucial for good reasoning. More recently, we've learned that reflective thinking predicts or causes changes in ethical or other philosophical judgments, even among philosophers. We're already learning that thinking about philosophy could make people think more reflectively, but philosophers are not alone in this preoccupation with reflective thinking. Nowadays, computer scientists are also arguing for the importance of reflection in reasoning models. Although there are benefits to reflectively stepping back from our initial impulses to become aware of more reasons and alternatives, plenty of good evidence suggests that reflective reasoning can also delay or even hinder decisions. So even if some of what we admire about human and artificial intelligence is a capacity for reflective reasoning, reflection can fail to fulfill our goals. Section 2.4. Idealized rationality. We can also become so obsessed with rationality that we fail to recognize other important factors. Consider certain economic notions of rationality. Since at least John Stuart Mill, economists have been accused of overly idealized theories of human rationality, such as perfectly self-interested agents. Of course, the history of the Homo economicus ideal is more complicated, and even Mill admitted that no political economist was ever so absurd as to suppose that mankind are really thus constituted. Nonetheless, a contingency of economic models seem to assume that human decisions seek to maximize or else continually increase utility of one sort or another. By the 1950s, however, cognitive scientists like Herb Simon had argued that models should take explicit account of the internal as well as external constraints that define the problem of rationality for the organism. These arguments eventually led to models of bounded rationality, which can better capture how our decisions often fail to maximize or even increase utility. So, even if we want reasoning models to be large, reflective, or rational, we must admit how various constraints can prevent them from optimizing these outcomes. There may also be constraints or circumstances that prevent us from wanting these outcomes from intelligent systems. Fortunately, some computer scientists have already realized the diminishing returns on further investment in the size of reasoning models, compared to the returns on more efficient architectures or inference techniques. Section 2.5. Dual systems approaches to intelligence. There's a growing body of evidence in favor of a dual model approach, a la dual process or dual systems theory. For example, Jan and colleagues found that pairing one small language model with another small language model that serves as a reflective system allowed these small hybrid systems to compete with larger models that had more than 10 times as many parameters. These hybrid systems instantiate both aspects of reflection. Rather than automatically accepting output from the default system, a reflective system reasons about it further, the machine version of dual system psychology. Others have also realized how pairing a small model with a larger model can offer a promising trade-off between performance and computational efficiency. For example, Sheng et al. Found that multi-model systems can achieve state-of-the-art reasoning accuracy and solution diversity at a fraction of the token cost. These results suggest that dual or multi-model architectures may be key to yielding the reflective reasoning and rationality that we expect from intelligent systems, but without overlooking other goals or constraints. Of course, deploying multiple language models does not guarantee high performance at lower cost. Like model parameters, more models are not always better. So I'm not proposing that we replace obsessive pursuit of model size or other factors with obsessive pursuit of additional models or maximally reflective inference. Rather, I'm proposing a form of pragmatism. Section 3. Strategic Reflectivism. Pragmatism about reflection. The core idea of this paper is that one key to intelligence is pragmatic, rather than perpetual deployment of reflective reasoning, a view that I've been calling strategic reflectivism. By tactically deploying reflective inference only when doing so is probably worth its costs, strategic reflectivism synthesizes pragmatism with strategic reliabilism. Strategic reflectivism is less optimistic about reflection than reflectivism, which holds that reflection is crucial for good reasoning, yet more optimistic about reflection than anti-reflectivism, which argues that the benefits of reflection are illusory. Strategic reflectivism has many implications. This paper will focus on the systems we study in cognitive science and computer science. Section 3.1. From strategic computation to strategic reflection. Consider an analogy with heterogeneous computing, which integrates multiple processing core types. For example, chips may contain both performance cores and efficiency cores, both general processing units and specialty processing units, such as graphics processing units or neural processing units. Such heterogeneous systems architectures can outperform the best homogeneous architecture multiprocessors, often in less time and with fewer resources. Strictly speaking, strategic reflectivism is not committed to the claim that properly reflective inference requires multiple modules or models or systems or cores or units, etc. Reflection need only involve, first, deliberative suspension of the initial response, and 2, awareness of additional reasoning about that response. So just as one human can back up or step back from their initial response and then consciously answer a question such as, "Shall I believe that?" one machine can, in principle, iteratively prompt itself with questions about whether to endorse its own output. Nonetheless, there are a few lessons we can draw about intelligent systems from the efficiency and performance of multi-core or multi-unit computing systems. Efficiency. Like heterogeneous computing systems, intelligent systems that can switch between default and more reflective inference can better optimize performance efficiency trade-offs than standard inference or always reflective inference systems. For example, Sui and colleagues used a meta-reasoner to evaluate a summary of each thought in a chain before executing any strategy, and their meta-reasoner method achieved better performance cost trade-offs than many other reflection protocols. Pragmatism. Heterogeneous computing requires some sort of meta-process to determine, among other things, when to recruit additional cores or core types. Strategically reflective systems also need a method to efficiently allocate the resources necessary for reflective inference about default intuitive responses. Ideally, this metaprocess would function automatically and adaptively. One approach might be a, quote, introspective, end quote, Monte Carlo tree search that identifies and starts with the most promising nodes during inference. This kind of metaprocess may learn to let intuitive inference handle, quote, common sense or general world knowledge, end quote, and thereby save resources for more tricky, multi-step tasks that are more likely to require reflective inference. Section 3.2, when to start and halt reflection. As with computing, there are multiple ways to determine how to allocate resources in intelligent systems. Bounded reflectivism synthesizes evidence from cognitive psychology to predict, among other things, when humans will, or should, reason reflectively. Tasks that seem novel, high stakes, or imaginative may nudge people to reflectively step back from their first impulse and consciously consider reasons or alternatives. We may also want to reflect when our first intuitive or unreflective response conflicts with other beliefs, or if we merely lack confidence in this initial response. Of course, reflection can be interrupted or even prevented by factors such as cognitive load or distraction. And these insights from reflective thinking in humans may provide insight about other strategically reflective intelligent systems. For example, when standard inference detects that a prompt or task requires knowledge that is unlikely to be in the system's training dataset, it would seem prudent to recruit another model or inference step to reflect on the default model's output. Alas, such out-of-distribution data is often undetected, so systems may also make decisions about whether to recruit a reflective model based on the confidence assigned to the default model's output. Lower confidence scores could indicate opportunities for more reflective inference, depending on the stakes, of course. In principle, conflict detection could be handled by the default model, as in self-consistent chain of thought reasoning or in parallel processing. However, given the aforementioned evidence about the superficiality or even inferiority of some chain of thought reasoning, another reflectivist model or metaprocess may be needed for optimal conflict detection. Halting thresholds for reflective inference may also scale with stakes, familiarity, resource load, and other factors. For example, a priori budgets for inference cost or time or other variables could prevent further reflection when reflective inference exceeds allotted resources. Of course, more automatic and adaptive stopping rules would be ideal. There may be many more factors besides familiarity, stakes, etc., that should determine when to intervene on lower cost default inference with higher cost reflective inference. And some intelligent systems may determine when to start and stop a reflective model based on goals besides just performance and cost savings. The main point of strategic reflectivism is that reflective reasoning and its resources should be allocated according to the system's goals, optimally fulfilling competing goals wherever possible. In short, strategic reflectivism treats reflective inference as a means, not an end, a tool, not a goal. Section 4. strategically reflective collective intelligence systems. There's no need to restrict strategic reflectivism to one human or one artificially intelligent system. Collective reasoning may also benefit from strategic reflection. Indeed, humans who reflect together often perform better on tests of reflective thinking than those who reflect alone, raising questions about strategic human-AI reflection. Perhaps the most straightforward strategically reflective human-AI team would involve a human as one system and a machine as the other system. Determining which one handles reflective inference may depend on the task, or the human's expertise, etc. So human-AI reflection can take many forms. Consider the implications of strategic reflectivism for a few domains of human-AI teaming. Section 4.1, Debiasing. Concerns about bias in humans and machines are voluminous. Before the onset of popular consumer-friendly AI systems, there were ongoing debates about how to measure and ameliorate human biases, and many of these biases have been detected in machines as well. Consider what pragmatism of strategic reflectivism implies about how to deal with human and AI biases. Wisdom in unreflective crowds? More than a century ago, Francis Galton noted how to yield more accurate estimates by merely aggregating the judgments of crowds, even when members of the crowd are not reasoning reflectively. There's now evidence that human AI aggregates yield better medical diagnoses than entirely human or entirely AI aggregates. You might be thinking that such judgment aggregation does not constitute reflective inference, and that's part of the point. Aggregation is often less tedious or costly than reflective inference, and the wisdom of an unreflective crowd is often good enough for many purposes. Indeed, aggregate polling results, stock market indices, and weather forecasts are often informative and corrective before expert analysts reflect on them. So the strategic reflectivist should acknowledge that when judgment aggregation is easy, more reflective inference may not be worth its opportunity costs. Biased compared to what? There is no shortage of public concern about bias in decision-making, especially when there are proposals to automate otherwise human decisions, a la algorithm aversion. Alas, these public outcries often neglect opportunity costs. It may be true that the new regime of decision makers is imperfect. We may even know precisely how a new decision system is biased. Nonetheless, mere existence of a bias is not enough to dismiss a system or its conclusions. Strategic reflectivism reminds us that for complaints about bias to be actionable, they must demonstrate that a more reflective system is both viable and better at optimizing the trade-offs between our competing goals. Until such a criteria are met, a complaint about bias in intelligent systems may be no more potent than common complaints about collective checks and balances, to which Churchill famously responded, "Democracy is the worst form of government, except all those other forms that have been tried." Section 4.2, Decision Aids. Decision aids are designed to help people prevent mistakes, overcome bias, or improve their decisions more generally. And there is already evidence that non-experts seem to have benefited from tools like chatbots when it comes to fact-checking and even understanding one's medical information. These examples do not allow us to conclude that AI assistants will improve all decisions. Indeed, human medical experts assisted by GPT-4 have performed worse on average than both the language model itself and their unassisted colleagues. So, insofar as those results generalize, strategic reflectivism may recommend employing AI-assisted reflective thinking more in non-experts than in experts. If these results do not generalize, then the lesson may just be that some decision aids are more effective than others. Section 4.3, Data Annotation. Making sense of unstructured data can require enormous human resources. In medicine, inexpert human-AI teams have more accurately annotated low-certainty images than inexpert humans, which implies an opportunity to better allocate busy and expensive experts to high uncertainty images. that are not as well annotated by the inexpert human AI teams. We can debate about how to classify those two image annotation pipelines as intuitive or reflective. After all, when non-experts receive feedback from an AI system or vice versa, they may reflectively decouple from their initial annotation to consider some alternative annotation inspired by the feedback. And in principle, both the human AI team and the expert could competently complete some annotation tasks without reflectively backing up from every response to consider alternatives. So the implication here is not that inexpert human AI teams or human experts exhibit only one of the two systems from dual process theory, intuitive or reflective, system 1 or system 2. Both groups can reason either intuitively or reflectively. Rather, the implication in this case is that strategically reflective systems can decide whether to deploy their reflective reasoner, human or AI, based on factors such as task domain, the default reasoner's expertise in that domain, or some combination thereof. Section 5. Conclusion. The first key claim in this paper was that reasoning architecture can matter at least as much to the success of intelligent systems as factors such as size, chains of thought, or other superficial indicators of reflection. Indeed, empirical studies of language models often find that properly dual model systems can be more efficient than larger single model systems. However, history reminded us that resource-intensive reasoning is not always worth it, and maximizing one form of utility is unrealistic. Insofar as we care about real-world decisions and actions, we want some kind of pragmatism. So strategic reflectivism proposed pragmatic rather than permanent deployment of reflective inference. Like the performance and efficiency cores of heterogeneous computing systems, systems capable of switching between more or less reflective inference can outperform standard inference systems or perpetually reflective systems, often with less cost and time. Importantly, strategic reflectivism is agnostic about the reasoning content and its reasoner. Reflection can be unimodal or multimodal, and it can occur in humans, machines, or collections thereof. So the view's insight and normative implications are actionable for nearly any field that develops or studies or uses intelligent systems. Business, computer science, decision science, education, epistemology, healthcare, intelligence analysis, policymaking, etc. Finally, strategic reflectivism remains actionable even if the empirical results cited herein fail to replicate or generalize. Indeed, the more we learn about the contextual value of intuitive and reflective reasoning, the more strategic reflectivism can advise its stakeholders. If you liked the Upon Reflection podcast, subscribe wherever you find podcasts, leave a review, or just tell people about it. You can also follow my daily posts about cognitive science on Blue Sky at birdnick.com, on Mastodon at birdnick, and all the other platforms. Comments and questions can be submitted at birdnick.com/contact. This episode's affiliate partner was Roadrunner Sports. To check out what you can buy on their website or in one of their stores, check out the affiliate link in this episode's description.